The next repository we're going to look at is the schemas repository, which contains the version schemas for the property data trust framework for digital residential property data exchange. The aim of this framework is to enable the frictionless exchange of property data between software products and services, supported by trusted information regarding the provenance of the data. And we'll talk about how the schema enables us to do that. In terms of the actual data fields, the initial goal of the schema was to encompass all the requirements of the home buying and selling group property pack with BASPI, but more recently we have moved to centering the schema around the National Trading Standards guidance. And again, as we kind of go through the schema fields, I'll bring that out. Before we look at anything else, I think it's good to look at what was our inspiration in terms of how to structure the schema. So we use the OpenID Connect for identity assurance framework to think about how we can have claims about something and then also provide evidence against that. So although this spec is centered around identity, we have kind of made some tweaks to use it for property data, and this link is available in the schema repository, but specifically what we want to look at is how we represent verified claims. So this is the theme that you will also see in our schema. So there's an object, the root level object is called verified claims, and in there we have two sub objects. One is called verification, which contains the data about the verification process that was used to provide the corresponding claims, which are given in the claim section. And in terms of what can go in the verification section, again there is documentation here, and we kind of show some examples in the schema as well. So you can define what's the trust framework. In this case it's the PDF trust framework, the evidence that was used to prove the data. So there are various types: document, electronic record, a simple vouch, an electronic signature, and then different types of attachments as well. So this is kind of a larger example of what the schema would look like, again with the verified claims at the top level, verification and the corresponding claims for that verification structured as shown. Let's go back to the repository. In terms of the folder structure, we have the source folder. In here we have the example, which shows different examples of how the data is structured. Now over time we have gone through different versions of the PDTF schema. So the latest version we are at is v3, and the schemas repository contains the actual JSON schemas that we use to map the data against. The tests folder shows how to take some of those examples in the examples folder and use different helper functions that show you how to manipulate the data, validate some example data against the schemas, sub schemas, and so on. And then there are some utility functions as well, which help you to contribute to the schema if you wanted to. So we'll go through each of these step by step. To go further, I'll switch to my code editor because some of these files are quite large, so it will be easier to navigate them here. So again, I'm in the same schemas repository and I'm on the master branch. So let's go into the source folder, schemas, and possibly the verified claims is the top level schema, so that's the best to talk about. There's a readme here which will take you to the OpenID spec that I was just showing you. But in terms of this schema, we, as I said, we have the verified claims at the top level, and then in the verified claims definition we have the verification, which has trust framework, time, evidence, and the actual claims itself, which is the information about the property in our case. So any information that's coming through must be coming in this format, and this specific claim information must come in the claim schemas that I'll come to shortly. So again, just to make this easier to understand, there is this examples folder. We'll go into V3 and let's look at a documented vouch or an electronic record. So here there is a claim made about council tax. The value of the council tax band is D in this example, and then some more information about council tax affecting alterations, and then the corresponding evidence can be also provided against this claim, which is kind of shown here with an example of, like a proof of address, where the address came from. So this section is quite flexible at the moment, but it follows the schema that's defined here. And then similar for a electronic record, it could be that, okay, you are storing some information about the address with line 1, line 2, town, county and postcode, and then the corresponding evidence could be the Royal Mail postcode address file. Instead of like having like a nested object here, we use a JSON path annotation here. So we give the entire path right till the actual data, and then the actual data is shown here. And in this way, you can kind of give multiple sub schemas and then the corresponding verifications about those claims. Now let's look at the actual schema itself. So on the left here, let me minimize this. I go into schemas, and again there is V1, V2, which you can ignore as they are older versions. The latest one for now is the V3. And then let's go into the combined.json file. So this is a very large JSON file, but I've collapsed various properties here to make it more readable. So it's a draft 7 schema, and it's kind of acts as a code schema for all the information about the property. And I'll come to what these fields are: TS6 required, NTS required, and so on. But let's look at the specific data field. So there's a JSON properties label here, and inside that there are different sections. So there's a transaction ID, which is the UID for the transaction where this property is being sold, some external IDs that can optionally be provided, the status of the transaction, the participants of the transaction. In this case could be the business participants, such as the conveyancers, brokers, or the buyers and sellers themselves. And then there's the property pack. So the property pack again is a very large collection of properties. If I expand its properties, you can see it has various sets of information: the address, UPR and location, price information, and a lot more stuff. These sections have been derived from initially the home buying and selling group property pack, but more recently, as I said, the NTS guidance, and it's separated into well-defined sections. If we kind of zoom into a specific section, the address is probably the simplest one. It then has properties to collect information about the address. So line 1, line 2, line 3, town and postcode. Similarly, the other sections will have like fields related to that parent section, and then it can be like quite nested depending on the detail that is required. The next thing we should probably look at is the various reference fields. Now obviously this schema kind of acts as the superset for all the property information that we are interested in, but in the context of a specific form such as the BASP, it will not have the detail of every field that's in this schema. It will only be interested in a certain subset of fields. So how do we identify which of these fields are relevant for certain forms? So in this case, let's say if we take the example of BASP, address is a relevant field for BASP. So how do we tag that? So in this file, we would add something called the form name followed by the ref keyword. So BASP ref, and the value of that is just the identifier in the actual form. What's the actual identifier for that field? So the address field in the BASPI form would be tagged as section A 1.1, and then the subsection could be A 1.1.1. So in some cases the subsections might not even have a reference in those forms, but in that case we just kind of use common sense and do just like a child level mapping. So this actually doesn't exist in the BASPI form, but because this is 1.1, for this it makes sense to be 1.1.1. So similarly, for every field that is referenced in the BASPI, we would add a corresponding ref, and then you will see something similar for TA6, TA7, TA forms, PIQ forms, and so on. The other thing is again related to the forms, like different forms would have different fields as required. So BASPI might have line 1 and postcode as a required field. Some other form might have line 1 town and postcode. So again, to capture those business rules related to forms, there is a form names followed by required field, and there you can specify which of these properties are required for that specific form. And yeah, that kind of covers the high level of this schema. So as you kind of clone this on your own, you can go through the details of the schema and kind of see where the detail of what fields are there, and then if you are interested in adding more fields, there is a procedure to do that which I'll take you through. So once this combined JSON has been defined, as I said, this is a superset for everything, and it also has some non-standard JSON fields. So how do we actually make use of this schema to validate various inputs that we're getting from the user? This is not a standard JSON as you can expect, because it has some custom fields. So there are some utility functions that we have provided. So there is a utility function here called extract overlay. The input to this extract overlay function is the combined.json file, and once you run this script against the combined.json file, two different things will happen. The first thing is it will create this file called pdtf transaction.json. So what this is it's basically a mirror of the combined.json, but it removes all these form specific tags from the schema. So this is like a well-defined standard JSON which can be used to validate any schema that's provided using a standard JSON library. So this is everything in combined JSON without the form references, form required, and so on. So this allows you to do any various kinds of validations of the full schema or sub schema. The second thing you might be interested in is what do we do with these form fields themselves. So again, when you run the extract overlay function, as you can see here, there is a array here called extract fields, and it will extract information that is tagged in this manner. So BASPI ref, TA6 ref. So whatever is like something ref or something required, this script is going to extract that into this folder called overlays, and it's going to create a separate file for every form that we have tagged. And what this will contain is it will extract all the fields. In the case of BASPI, it will extract all the fields that are tagged with BASPI. So these schemas can be then used in your front end to show the fields that are relevant to that form. But when you save this information, you are saving it against this schema. And because a lot of these fields are shared between forms, for example, like address line 1, this you will find in BASPI, and you'll also find the same in TA6. So when saving this information, you save it once. When rendering this information, you can render two different forms, or 3 or 4 or 5, depending on how many forms this field is referenced from, like one source. So if you change something in one form, it will be reflected in many, and then if you change something in the source, it will be reflected the other way around. So that is one of the powerful features that we enable through these schemas. That kind of covered the overall high level structure of the schemas repository. if you go back to the GitHub repo, in terms of contributing to this, again, it's the similar format as the API repository. So you would raise an issue about some changes that you want to make, or a new form that you want to support, or new fields that you want to support. People would then comment on the specific request, and then if you're ready to do that, if you have the capacity to do it, you can also raise a pull request referencing that issue and then creating the fix, and then someone who doesn't belong to your organization but is part of the PDTF can review that and then add comments and merge as required. So just to recap that contribution process, you would add certain fields here, you would run the extract overlay function, which would update the PDTF transaction JSON, it would update the overlays, you would then review those changes and then merge them if all is good. The schemas are also published to our npm package, so we do version the schemas using this version, and then you can either use the schemas directly as is from here, or you can then download the schemas from the npm repository as well. And to add to that, again, all these key sample, there are certain tests as well to help you run through some examples and again get a deeper understanding of how the schemas can be used, how you can validate, and so on. So this is around validating the specific claim section of the schema, and there's another test for validating the overall verified claims containing the verification and the claims. These are all in JavaScript, but obviously they use like very standard JSON libraries. So if you wanted to rewrite this in Java or any other language of your choice, it's quite easy to do. Yeah, that is it for this demo. Thank you.